Hi, this is Paul again. I've got another new video to show you, and I'm calling this CubicWonder Slicing for 3D bonding geometry. Okay, we'll start this video by showing you a string of two Plato cubes and a Bucky cube in the center. Now, what is special about CubicWonder is that there are integrated geometry with the cubes. Now, the Bucky cubes and Plato cubes are split into 40 pieces, geometric pieces. Now I'm going to move the Plato cubes to the center to meet, and then you will see we have some beautiful integrated geometry of the Bucky cubes and Plato cubes. I'm going to repeat this animation for you to see it going together again. Isn't that something? In my earlier videos on YouTube, I showed that each cube is made up of 8 Chica cubes. Let's convert this to Chico cubes and take a look. I think this is very interesting 3D geometry here. It's a pity that intellectuals are not interested. I'm only getting 1 or 2 views from the whole of United States of America. I guess it's obvious that mathematicians do not like 3-dimensional work. I guess that's the way things go. Anyways, the reason for this video is to look into the slicing of this 3-dimensional system. So if you look in front, I've put 2 strings together, and it shows the slicing of the Bucky and the Plato. Notice the Plato splits into 3, and the Bucky splits into 2 and then splits into 3. I call this 2/3. Now, something important, only the green part can be sliced away, or the white part can be sliced away. Now I'm going to show you the Bucky and Plato cubes gone together as integrated. I would say that when it's integrated, it takes on the Plato, and that will be 3:1. The reason I'm saying this is because the Plato cubes are the boss cubes. The Bucky outline is optional. You get a Bucky in the center of 8 Plato cubes. Okay, I'm going to bring in 2 Bucky cubes and a Plato in the center. So this will mean the Bucky cubes will be the colors of the division. I realize this can be a little bit confusing, but I think it's important for 3D bonding geometry, because I don't think bonding geometry comes out of flat planes as they teach in universities, because I think everything comes in 3 dimension. A flat plane does not give any weight to a metal. I think this 3-dimensional approach is very important. I've got something else to show you now. In front, I'm showing you how a wonderful 3D bonding geometry will come out of using Chica cubes. Let's take a look. Okay, I'm just showing a Plato cube in the center. Now I'm going to change this and just put a center green and white octahedron. Now I'm going to whittle down the Bucky cubes into Chico and Chica cubes. Now we're going to bring the top and bottom Bucky cubes to the center and show the integrated geometry of the Plato cube. I'll repeat this animation so you can see it better. Okay, I'm showing Chico and Chica cubes, but I'm going to convert it to the internal geometry, the purple and yellow tetrahedrons. This can easily be done by removing the red, cyan and blue pieces. Okay, I'm going to do something interesting. I'm going to change the top molecules with the Chico cube. And you can see what's happening. It's taken a bend on the top. So it's straight on the bottom and it's taken a bend on the top. Now this bend can follow 8 vectors of the cube. So this is a big discovery. Okay, I'm going to take away the red, cyan and blue corners of the cubes, and that will leave us the purple and yellow. Now this 3D geometry can use a new cube outline. Let's put it in. And you can see that the green corner piece of the bend is part of a new octahedron. Let's put it in. Okay, I think we'll zoom in a little bit and then we'll give it a rotation and see what we've got. It looks like the Chico and Chica cubes are a very important system for the geometry of the 3D elements. I've been showing everything orientated to the long diagonal facing vertical. Now if you look at my videos, you will see that most of the geometry for DNA follows this long diagonal in the vertical position. Now for the rest of this video, I'm going to start using the XYZ axis because it's much easier to understand in this orientation. Okay, I'm going to show you first the slicing in the vertical y-axis. Now notice how the colors change as it's being sliced. This is a very important feature. And as you can see, it being sliced in the 3 X, Y and Z axis. Now earlier I showed that slicing could be 3:1 or 2/3. This one is exactly 2:1 slicing. Now there's something I'd like to add. This is not 4-dimensional work. It's all 3-dimension. And it's done in the X, Y and Z axis. And a cube can be put inside a cube without calling it a hypercube. That's what I say. So I guess I've shown enough 3D order for today. So to the people that think order is better than chaos, this is Paul saying thank you very much for watching my video.